accepted.
Hello everyone, my name is Bartek and I work for a company called Software Mill as a Scala software engineer. In my free time, I like to code, what must be very surprising for all of you here, enjoy reading books, and from time to time, I like to dive deeper into something related to the mathematics. And it is the reasons why we all here today. I would like to tell you about one of these peculiar mathematical curiosities that can actually impact our life as software engineers. But before we start, let's move through the levels on which math and software intersect with one another. First, we've got level 0, so binary system, all the zeros, ones, all the equations related to electronics, which in fact provide our software a hardware to run on, and by definition make our software runnable at all. Then we've got algorithms and data structures, which, as you probably know, have some mathematical foundations. This case is particularly visible in all the graph algorithms, which in fact originates from mathematics as a science, not from computer science. The next level is, let's say, the architectural level, where we've got things like, for example, CAP theorem. I know that we can probably spend an hour or so here discussing whether or not CAP theorem works, whether or not. However, in my opinion, it still describes some basic trade-offs we have to make while designing the distributed system, and thus it's quite a valid example. And what you probably may not know about a CAP theorem is that it is a fully proven mathematical theorem with all the required paperwork around it. And as a cherry on top, we've got monads, functor, applicative, applicative functor, semigroup, semi-monoids, and other category theory stuff that probably not everyone understands fully, yet we are happily using it in our daily life as software engineers, for example, in form of Java util optional. Before we move forward, I have one more question for you. What will be the value of B? For those who read the description of this talk, this will be probably easy questions, but nevertheless. Who thinks it will be true? Hands up. Okay. Who thinks it will be false? The same. Okay. And the correct answer is true. But why? Why calling all match on empty string will always return true? And what it have to do with math? Well, it has quite a lot to do with math, because the reason behind all of this happening is a concept called vacuous truth, which is a concept from branch of mathematics known as logic that is used to describe all the logical statements that are evaluated as true because their base condition, or more formally, antecedent, cannot be fulfilled. Or in more mathematical syntax, assume that we have a logical statement S, if P, then Q. Then, if P is false, S is logically true and is considered vacuously true. We can also define vacuous truth concept with a use of for all quantificator, this strange reversed A. You maybe remember it from your mathematical lectures on your studies. And in such a case, it looks more or less like this. And we read it in form of, for all the x's from a set B, if px, then qx. Then, if px is false for all the x's, our statement is evaluated as vacuously true and is considered logically true. I know that it sounds complex for a beginning, so let's try to make it more descriptive with an example. Let's consider such a logical statement. If there are any developers in the room next door, then they all work in Haskell. I know it is probably not the best example for a programming conference because there will always be some developers in the room next door, and I'm betting my life on it that all of them won't be working in Haskell. But nevertheless, it's just an abstract example. Here we have a base condition that is explicitly stated inside our logical statement, and it says that there must be some developers in the room next door. Additionally, we can have implicit base condition, for example, in the statement, all mobile phones in the room are turned on. And in this case, base condition is that there must be some mobile phones in the room next door. In both cases, if the room is empty, so there are no developers, there are no mobile phones, or the room is just pure physical vacuum, our statement is evaluated as logically true and is considered vacuously true. Okay, so moving forward, let's try to mix a little, and let's mix this mathematical syntax with plain English. Px is our explicit base condition, so that there are any developers in the room. Qx is our then clause, so that they all work in Haskell. And B is our set, so all the people in the room. And thus, we can rephrase the mathematical definition of vacuous truth to plain English form in something like this. For all the people in the room, if a person is a developer, then they must work in Haskell. I hope that now it sounds more reasonable for all of you. I hope so. But as for now, I'm speaking about quite abstract things, like some mathematical syntax, math, logic, which is quite abstract thing in and of itself. Some Haskell developers, like how many of you even know somebody who writes Haskell? Any hands? Oh, 2. Less than I expected. Well, stream and all much fits perfectly into vacuous truth definition with for all quantificator. And we can read it in form like this. For all the elements of our stream B, if a predicate P is valid for all the elements of our stream, return true. As simple as that. And here is also a beautiful screenshot from IntelliJ IDEA that proves that our computers can into maths and that we can just replace this whole expression with true because it will always return true. If you don't believe me, you can check it yourself. I checked it yesterday, it worked. Maybe it changed since then, maybe, hope not. Okay, some of you may say that it's only in Java, it's just coincidence. Well, maybe it is not. However, Java is not the only language with such a behavior, and stream and all much is not the only construction with such a behavior. For example, in Scala, for all method, which is present in many collections, also return true for empty arrays. In JavaScript, method every from array prototype also return true for empty arrays. What is more, in Python and Kotlin, built-in method all, which tests if all the elements of an array are true, will also return true for empty arrays. Additionally, some time ago, I have a pleasure to speak with people from Neo4j, and via manual testing, we came to the conclusion that built-in method all from Neo4j will also return true for empty arrays. So maybe everything is a coincidence. I hope not. Maybe it is. And when a hell freezes, math will be actually useful in real life. So vacuous truths daily. More than when a hell freezes, which I already used, we have when a pigs fly, when shrimps learn to whistle, and when a star start rising in the west. And additionally, all other absurdities based on obviously false or impossible to meet condition. If you want to be 100% mathematical nerds, as me, then we can count all the statements based on if I were you as vacuous truths. I know it is a figure of speech more than anything else, but nevertheless, as I said, it's from a mathematical point of view, it can be vacuous truth. And what is more, these are only the examples which I managed to find as non-native English speaker. And if you are more proficient than me in English, then you will probably find some more. And what is more, I'm making quite an educated guess as for now. I believe that each language have its own set of such statements in a common speech. I don't check it, but I'm guessing. Vacuous truth, the recap. Just remember that such concept exists. It originates from branch of mathematics known as logic, represents the logical statements that are evaluated as true because they have false base condition. And it is the reason why all match and their counterparts will return true for empty sequences. And as you could see a moment before, can sometimes occur in our daily life. If you like my talk and want to stay up to date with what I'm doing, you can find me on LinkedIn under my real name, on Medium and Twitter under this handle, and on Software.me's blog and DZone, where I'm trying my skills as a writer. If you have any questions, now it is a perfect time for them. Anyone? Anything? Okay, so I see no questions. Then I hope that everything was understandable and you know what is vacuous truth. Thank you for your attention, have a great day and have a great rest of the conference.